I think I need Zeus on this. Let's go. Zeus,
Hi Ben.
I've been looking for you just now.
Oh really?
Yeah.
What is it?
I got a bunch of questions for you.
Just ask.
Zeus, do you know what happened during a regenerative braking of an electrical car?
During regenerative braking of an electrical car, when an electric vehicle slows down, its motor will work in reverse and becomes a generator. Instead of wasting the kinetic energy of the car as a heat, the generator will produce the electrical energy to replace those energy. However, this energy comes in a sudden, intense burst because braking happens very fast, you know, right?
Yes.
Therefore, the vehicles will need a device to absorb this energy immediately, which is capacitors that I have read just now in this book.
Wow, that's the coincidence here.
Yes. Ben, do you know why capacitors are used in the regenerative braking?
I think capacitors are suitable because capacitor can charge extremely fast. Based on what I searched just now, unlike batteries that can rely on slow chemical reaction, capacitors store energy by simply building up the electrical charge on metal plate. Since this process is physical, not chemical, the charging happens almost instantly. This makes capacitor perfectly for capturing fast, high-power energy bursts from braking. Am I right, sis?
Yes, you are right, Ben. Besides, capacitors have a high density of power. This is due to the fact that capacitors can accept and delivers power at very high rates. They can safely take in large amount of electrical power in a short time without overheating or degrading. This is important because regenerative brakings can produce a very high power momentarily. And then, besides that points, capacitors also have very long cycle life. Capacitors can be charged, discharged hundreds of thousands of times with almost no wear and tear. Because braking happens so often in daily driving, a long cycle life is essential. Batteries would degrade quickly under this repeated stress, but capacitors can handle it easily. Isn't it interesting for you? Ben, do you remember the equation that Sir Shah had taught us about the energy stored in the electric vehicles yesterday?
I think I've seen it somewhere. Let's go. Look, is this one right?
Yeah, that one, this one.
I think I can explain this formula. So our energy will always depend on V. So our energy will depend on the square of the voltage. So if the voltage produced is higher, so our capacitance will also increase the same amount of V. Is that right?
Yes, that's right. For example, if the voltage is double, then the energy stored in the electrical vehicles will become 4 times larger.
This means a strong and sudden event which generate a high voltage result in a higher amount of the capacitor, right?
Yes, that's right. In conclusions, capacitors are ideals for regenerative brakings because they can charge very fast, handle high power, and last for many cycles.
So the stored energy is directly related to the braking voltage because the formula is now half over CV squares. So the higher voltage means the significant more energy is stored. So I think it's time for class. Let's
Yeah.
go.
Let's go.
Merry Christmas, everyone.
Merry Christmas!